Welcome again to the second part of this video. And what you're going to do right now is look at function currying a little bit more in detail. So the idea with function currying is, let's say I have a function in math. So let's just come back to the math side of things. So to just get an intuition feel for function currying in functional programming, let's just define a function in math of two variables here. So let's say I have a function x comma y, and there's simply nothing but x squared plus 2y. Okay. Now, what this means is that if I were to call this function f, and let's say I pass in for x the value 2, and I pass in for y the value 3, it simply means that in my function f, I'm just going to replace wherever I see x's with 2's, so this becomes 2 square, and wherever I see y's, I'm going to replace that with 3, so this becomes basically, in this case, basically it's 2 times 3. And whatever is this value, that happens to be the final representation of f of 2 comma 3. Now, we also understand from math is that if I were to call this function f of x comma y with just one parameter, so let's say I call this with f of 3, or let's just be a little bit consistent with what I had earlier. So let's say this is f, and I'm going to call the function f with just 2 comma y. What does this mean? Well, this means that I'm going to see wherever I see x's, I'm going to replace that with 2. So this is going to be 2 squared plus 2y. Now, I'm not going to replace y with any value because y is still y in this function f here. Now, what's interesting is that after performing this substitution for x by replacing x with 2's, what I really now have is a function of one variable. I mean, this could be thought of as a new function g of y, which is basically 2 squared plus 2y. So if I call a function in math with just, in this case, with some partial arguments, where I'm just passing in one of these arguments, and this in turn gives you back another function, a function of that many variables that were not passed in the original function. So this gives you back a function of one variable. Okay, so how does this map to, or how does this connect with function currying, and what are its implications in F sharp? In F sharp, if I go back and look at this function that I defined in my last video, where I had this function v, which represented the volume of my cylinder, this v can be thought of as a function of two variables. So this is a function of two variables r comma l, which is simply nothing but equal to pi r squared l. Okay, now if I call in v with just 10 comma l, where I'm going to replace wherever I see radius with 10, this basically translates to 100 pi times l. What this means is that this piece over here is a function of one variable, that depends on l there. Okay, so going back to my functional type that I had originally for v, the functional type for v was basically, it was something that went from a float to a float to a float. And function currying is this idea that every function basically in F sharp, and again, if I would tie this up even with Haskell, there's this idea that functions just take in one argument. Okay, they just take in one argument. So if I had a function v, and this function v is a function that just can take in one argument, then the first argument could be this floating point value, which in turn returns back to you a function that takes in another floating point value as an argument. Okay, so a function that was originally a function of two variables can be interpreted as a function of just one variable, which in turn gives you back a function, kind of a subfunction that accepts or takes in as a parameter the another argument. Okay, so let's just try this out and let's get an intuition feel for this in F sharp here. So what I'm going to do is I'm just going to call v by passing in one argument. Let's say 10, just 10 there. Okay, and let's try to understand what g is going to be. Now, if I had earlier 10 and I passed in 20.0, the type of G we knew was a floating point number. This basically resulted this G had a value that was 6280.0, and we see that value over there, and the type of G happens to be a float. Now what you're going to do is you're not going to pass in the 20 there. If you don't pass in the 20 there, what's going to happen is that because v is being called, the function v is being called with that one argument 10.0, the type of G is going to be a function, that goes from a float to a float. And this is what the type of G is going to be. Okay, it's going to be a function that goes from float to a float. So let's just try this out. And let's just get rid of the 20 there. Let's just run this. And I can see that G is now a function that goes from a float to a float, which means that I can kind of do this slightly differently. I can say, okay, if G is a function that goes from a float to a float, how about if I call the function G with let's say 20. Now if I call G with this parameter 20, I'm just trying to obey the functional type. I'm just obeying the functional type that G is a function that takes in a float. I'm passing in that float there, so I'm just going to have this 20.0 there. And if I call G with that float, I'm going to get some value, which is going to be this float over there, and that value is going to be stored in my variable h there. So let's just try this. Let's just say 20.0, and if I run this, I can see now h over here contains the value 6280. Okay, and so this is basically what's the idea with function currying. We can even look at it. Let's look at one more example with function currying here. So let's say I have a function. Let's say I have a function addition. ADD. I just spelled it correct. This seems correct, and it's a function that takes in two parameters and just basically adds x and y. Now what I'm going to do is I'm going to use the idea of function currying, and I'm going to create another function. Let's say it's a function increment. Okay, and an increment, at least by definition, is a function that just increments things by 1. So I'm just going to say increment, and this is a function. It's a function. So I'm going to say addition, and addition is a function taking two variables. So I'm going to say addition of 1 and that's it. So let's just try to understand what's going on here. So addition, I'm already passing in 1 as my first parameter there. This in turn is going to give you back a function. It's going to give you back a function that has been partially applied, which means that the type of addition, if I go back to addition is a type that takes in an integer, and gives you back an integer. Okay, this is the type of addition. And what I'm going to do now is I'm just going to say addition by passing in just 1. So addition with just 1 gives you back a function that goes from an integer to an integer, which is basically what increment is. Okay, and so the function type of increment is basically a function that goes from an integer to an integer. Now if I say increment with, let's say I pass in that integer as 6, I should get back a value of 7. So I'm just incrementing 6 by 1. So this is a really good example of code reuse in functional programming. So so let's just try this out. Let's just first run this and make sure that we have our functional types as expected. This is what addition is. Addition is basically a function that in this case goes from an integer to an integer to an integer. So it's a function of two variables there, and if I partially apply that, I have a function increment now that goes from an integer to an integer. So now what I can do is I can simply come back to my code, and if I say let h equals to increment of 7. Well, if I'm going to increment 7, and if the definition of increment is I'm incrementing something just by 1 year, h is going to contain a value 8 there. So I can see h contains the value 8. And if I say let L equals to increment of 8. Well, increment of 8 basically means I'm just going to increment 8 by 1. So L is going to contain the value 9. and I can see in this case L contains a value 9. So again, what we've done here is a really simple example of, we've looked at some simple examples with function covering, and I hope you found this a little bit useful, and we're going to look at in the next videos some ideas with recursions. We're going to look at higher order functions, and we're going to look at maybe a little bit of lambda expressions.